Hello, this is going to be a demonstration of analyzing your own data that you've captured. You could capture your own data within your business. And if you had your own large language model running within your company on your server, you could actually analyze your own data, make sense of it, and query it using semantic search. Now, if you don't know what semantic search is, I'm going to demonstrate it here. Now, once I've demonstrated this, hopefully you will want to investigate this or find out more, which I'm happy to discuss with you. So let's look at some websites. I'm going to look at a recruitment website because I think this is a good example. But this is obviously a public website, but it could also be internal documents. So what we'll do is we'll gather the data to start with. And once we've got the data in our system, which I won't go into the technicalities of it, but we're going to gather the data. So this is the data gathering phase, and it's human in the loop because I'm a human. I'm not doing this automated. Now, if you automate data collection, web scraping, it's expensive. You can get banned. It's a bit of a grey area on whether you should even be gathering it or not. Whereas if you're visiting a website as a human, it's a little bit more acceptable. And you're not hammering their servers, which is arguably the bad bit, the bad thing, which is to be discouraged. So let's just look at this. And what I'm doing here is I'm gathering the data, and we can highlight whatever we want to highlight. So in fact, I'm just going to highlight the price and the product description, and we will put that into here, send to the back end. Another Lenovo. So we're gathering information on, as you can see, on jobs, laptops, and all of this data is going into the same location. But when we search for it, we will be able to search for the highest ranking results, the highest scoring results. So obviously we'll find laptops, but the beauty of what we're about to do is we're actually going to find based on what a human might ask rather than just a keyword search. Lenovo ThinkPad, let's get the description as well. So we're gathering the data, and next we're going to ask some questions about it. So let's analyze what we've got so far. So find me data about a typical Lenovo used laptop. What is a typical amount of RAM? I'm expecting it will come back with some search results, and then it will summarize and say, okay, 16 gig. I was expecting 8, but well, 8 gig is also present in some models. 16 GB apparently appears to be frequently occurring, thus typical specification for a used Lenovo laptop. Okay. Now, can you tell me a bit about the typical skills needed for a programmer job, e.g. senior dev? Is cloud AWS a common requirement? So you can see it's finding the results and then doing a nice little summary at the end. In summary, for a senior developer, strong foundation in software engineering, proficiency in relevant programming languages, and significant experience with cloud platforms, especially AWS, are highly sought after. Now, these results are slightly skewed because I probably collected 3 out of 5 jobs that mentioned AWS. So this is quite a small data set. As it grows, as we import more things, then yeah, you'll get a more rounded answer. But you can see what it did. It went off and collected the actual payload, and then it summarized it to a nice human-friendly answer. So it's actually citing some of the explicitly listed. So it's actually using some of the featured text to back up its reply. So it's using evidence, which is good. So let's look at some real estate, because this is another great use. Because if you're looking for a house, you might be looking for, a small house in a town or small house near the shops. And we know that a small house near the shops could also be a 2-bed and terrace town centre. So let's actually just prove that we can collect data. And again, if you're collecting data as an estate agent, you probably have got time to gather 3, 5, 10 new properties each day manually. That would probably be a better use of your time, and you can then scan through them rather than paying some web scraping proxy, paid scraper API, whatever, lots of money to just bulk ingest millions of results and properties, which probably aren't relevant at all. Let's do another one. So I'll just make a note of some of the features, because private garden. So rather than private garden, I'll ask for a secluded backyard. What am I doing? Copy. So I need to send it up here. So this is a browser extension, which is just transferring the text into the backend. So find me a house in Malvern area with just want to make sure we're not repeating anything which is private garden. So we'll say a secluded backyard. Oh, we've got an error. Okay. Use your MCP. It tried to use its own knowledge there. My prompt was a little bit. My original prompt was what we actually need here is the system prompts to be configured, which is something which I can do. This is an early evolution of the product. So I found a few properties in Malvern that might fit your criteria, specifically regarding private or secluded backyard. So it knows that secluded backyard is private. So 2-bed and terrace, house in Duke of Malvern. This is built around 2007. I suspect that was the one we just added, was it? Bramble Close? Let's see if Bramble Close crops up. So we've got the Victorian one. Okay, so it's possibly, or probably found even better ones. Poplar Gardens, private rear garden. But that's good, it's found. It's important to note that secluded can be subjective. These descriptions suggest properties with good privacy in their backyards due to features like fencing, hedging, and landscaping or end plot positions. So the combination of the large language model and the code which I've written has actually filtered out exactly what we wanted to filter. Let's go back to the search results, and we'll just do one more, and you can see how this will grow and grow as you add more data to it. So what's this? This is 189 Newton Road. It's got what, 3 words there, look. Chain free, livable, day 1, parking, ground floor, upstairs. Council tax band B. So when we query, we'll ask for low council tax. Use MCP. Find me a property in Malvern that I can buy straight away. So that's obviously the bit that's going to find no chain, and needs to be low on council tax also. Let's see what it finds. And it's found the one we've just added, so that's pretty good. I'm impressed with that. So this is a great product. You can gather your own data. You could use this internally without ever needing to use any internet paid AI models. You could run a server with a GPU with an open source model. That would then call my tool. So the tool that I've built is actually doing a lot of the heavy lifting in the background here. And you've also got the browser extension, which I've built. So with my browser extension, my tool, and a free open source large language model, you could run all of this without an internet connection.